Identify the characteristics of the following quadratic. Negative 2x squared minus 5x plus 4. Take just a moment to see if you can figure out the solutions to each of the questions below. All right, welcome back. For identifying the number of solutions, hopefully you remembered that you need to find the discriminant, and that uses the portion of the quadratic formula that is b squared minus 4ac. So here we want to find our b value, which is negative 5. Negative 5 squared minus 4 times our a value, which is negative 2, times negative 2 times our c value, which is 4. Now we should know right away that the moment we multiply our negative 4 and negative 2 together, we're going to end up with a positive sign here. And so we're going to end up with a positive solution, and that tells us we're going to have two real solutions. For those of you that need to see it just a little bit slower, let's go through that. Negative 5 squared is 25. Minus 4 times negative 2 times 4. Well, 4 times negative 2 is negative 8 times 4 is negative 32, so we end up with 25 minus negative 32. Where we have a minus a negative, which becomes plus. And so 25 plus 32 gives us what, 57? Which is a positive number. So again, two real solutions. Well, what is the vertex? Vertex, we just recently discovered, uses the part of our quadratic formula, which is x is being equal to negative b over 2a. So we want the opposite of our b value, so that's going to be 5 over 2 times a. 2 times negative 2 is negative 4. So our vertex x value is equal to negative 5 over 4. Now, yep, I get not a very pretty value, so we're going to have to do a little work with it. I'm going to come up here on the top right on the screen. Negative 2 times negative 5 over 4 squared minus 5 times negative 5 over 4 plus 4. Well, negative 5 over 4 squared, 5 times 5 is 25 over 16, and we're going to multiply that by negative 2, which will give us negative 50 over 16. All right. We have two even numbers, so they can simplify down. Let's see, both are divisible by 2, which will give us 25 and 8. Now, I don't have to simplify down it right now, but I can go ahead and see that 8 is a multiple of 4, so it's going to be easier for me to use a smaller common denominator. So, let's do minus 5 times negative 5 is negative 25, so I'm going to have minus a negative, which will make it positive. 25 over 4, which we wanted a common denominator, so let's do that again. Negative 25 over 8 plus 50 over 8. And again, we want a common denominator, so we're going to go ahead and make this common. So plus 32 over 8, which is equivalent to 4. Now, at this point, we have negative 25 plus 50 plus 32, which gives us 57 over 8 for our y value. So our ordered pair for our vertex, negative 5 fourths, 57 eighths. Certainly not going to be a pretty thing to try to graph, but fortunately we weren't told that we had to graph it. Is the parabola a cup or a cave? In other words, does it make a cup bowl up, or does it make a cave bowl down? Well, we should realize that we have a negative a value, so this is going to end up being a cave bowl down. An intercept form. So standard form we talked about previously, f of x is equal to ax squared plus bx plus c. And so we recall that from from standard form, you can find the vertex using your x equals negative b over 2a formula. And that will give you the x value of the vertex. You plug it in to find the y value of the vertex. Well, you can also do a similar thing with intercept form. So notice I have my two intercepts identified in parentheses. We've been spending a good bit of time being able to factor down quadratics into their intercepts or into their simplified factors that we can use to identify the roots or the intercepts. And so we're going to use this process today to figure out how to graph standard form. So we want to start with finding the vertex from the intercept. First, find the zeros or your x-intercepts. Remember, we'll do that by setting whatever your roots are, whatever your factors are, equal to 0. When you set them equal to 0, then you can solve to identify your value of x, and those would be your x-intercepts. Second, find the average of these intercepts. This average is the x value of the vertex. So remember that when we were dealing with quadratics and graphing yesterday, we talked about that axis of symmetry that fell between. Well, now we're focusing on the fact that we have a quadratic that intercepts the x-axis, and these x-axis intercepts must be equidistant from each other in regards to the axis of symmetry. So since they are equidistant from each other, we can find the midpoint between them by adding their values together and dividing by 2. Now, once we've found the x value, just like we did yesterday, we can plug into the equation to find the y value, and we end up with a vertex point. So let's give this a shot. F of x is equal to 1/2 times x minus 3, x plus 1. The first thing we want to do is figure out what these roots are. And I gave us fairly basic ones for the first problem. So our x here is x is equal to 3. Our x over here, x is equal to -1. All right. So in order to find the x value of the vertex, we take 3 and add it to -1 and divide by 2. 3 plus -1 is 2. Divided by 2 gives us a value of 1. Now, let's think about this logically, because we can already graph something on this parabola. We know that at x equals 3, 0, we have an intercept. So that's an ordered pair on this quadratic. We know where x is -1, 0, we have an intercept. That's an ordered pair on a quadratic. Now, logically, we can already deduce that right in the middle is where our line of symmetry would split this quadratic evenly so that both of our ordered pairs are equidistant. Oh, come on. Equidistant from the line of symmetry. So at x equals 1, we just need to know what the y value is. So let's plug that into our equation. 1/2 times 1 minus 3 times 1 plus 1. 1 minus 3 is -2. 1 plus 1 is 2. And we're going to multiply that solution by 1/2. -2 times 2 is -4. -4 times 1/2 is -2. So now we know that the y value associated with this particular x value of 1 is negative 2. So our vertex is 1, negative 2. We'll come over 1, we come down 2, and we have a vertex point. We have an axis of symmetry, x equals 1. Again, we can get that straight from our vertex point. And from here, we can deduce that our graph is going to go something like this. Now, if we want to be more precise, which hopefully you do, you're going to go ahead and grab another ordered pair. So we have 1, negative 2. Notice we already have another ordered pair. We have negative 1, which gave us a y value of 0. We have 3, which gave us a y value of 0. So now it'd just be nice to grab another ordered pair. Let's do something like negative 1, negative 3. We'll go ahead and do 2 more units. And 5, we'll do 2 more units. Now both negative 3 and 5 are equidistant from 1. And so when we plug the value into our equation, we should end up with a y value that is the same for both. So 1/2 times 5 minus 3 times 5 plus 1. 5 minus 3 is 2. 5 plus 1 is 6. 1/2 of 2, those cancel out, so we end up with 6 and 6. So we can come back 3, up 6. Notice that my original graph was a little shy on how far that curve should come out. Over 5, up 6. That ordered pair was a lot closer. So we should curve up something like that. We should curve up something like that. And we want to make sure that we're not looking so pointed down here because this is definitely not an absolute value. And we've graphed using our intercept form. Let's try another one. So x plus 1, the value of x plus 1 equals 0, minus 1, minus 1, x is equal to negative 1. So negative 1 is one of my solutions, and we can see clearly that 4 is the other. So negative 1 plus 4 divided by 2 gives us 3/2. Well, this is going to be a little less pretty, but 3/2 is my x value. We now need to find our y value. So we're going to plug into our equation. 3/2 plus, notice I'm going to change this to a fraction, 2/2 times 3/2 minus 8/2. 3/2 and 2/2 gives us 6. Sorry, what am I doing? 5/2. 3 minus 8 gives us a negative 5/2. 5 times 5 is negative 25. 2 times 2 is 4. So we have a y value of negative 25/4. Now our axis of symmetry, x is equal to 3/2. 25/4, let's see, 4 goes into 25 6 times, which would be 24, and 1 remaining. So we want to come back, go forward 3/2 and come down 6 1/4. That is our vertex. Well, let's see if it falls in between our ordered pairs. We have negative 1 as a root. Where's my pen? We have a negative 1 as a root. We have a 4 as a root. And sure enough, 3/2 is going to fall right smack in the middle of those two ordered pairs. And so we can fill in what we know. We got 3 halves. All right, we have 3 halves. Negative 25 over 4. We have an ordered pair that would be negative 1, 0. We have an ordered pair that would be 4, 0. Now it would be nice to find another ordered pair that gives us an idea of what's happening as the graph moves higher. Maybe something like negative 2 and 5. We're increasing 1 in either direction. You can choose what you want to plug in. I'm going to go ahead and use the 5. 5 plus 1 times 5 minus 4. 5 plus 1 is 6 times 5 minus 4 is 1. So that would equal 6. So if we come back 2, up 6, we should be able to go forward 5, up 6. And we now have enough information to put together a pretty accurate drawing of what this quadratic looks like. Let's try another one. Find the vertex and axis of symmetry, then graph. So let's start with our first. Negative x is equal to 0. Well, doesn't matter what number I put in for negative x, x will always be equal to 0 if x is 0. So one of my roots is 0. The other root, x minus 6 equals 0. Add 6, so x is equal to 6. There are our two roots. So we want to add our roots together, 0 plus 6, and divide by 2. Our vertex is going to have an x value of 3. So let's see if this makes sense. We have an intercept at 0, 0. We have an intercept at 6. Would it make sense for my vertex to be at 3? Absolutely. Well, let's figure out the y value. We have negative 3 times 3 minus 6. Negative 3 times 3 minus 6 is negative 3. Gives us a positive 9. All right. So that would mean that at 3, 9, we have a vertex. We can see very clearly that this is going to open downwards. It would make sense that it's going to open downwards because when we distribute, we get negative x squared, and so our a value would be negative. Since the a value is negative, it's going to cause our graph to flip, and so it would be opening downward. The axis of symmetry, x is equal to 3. The x-ordered pairs, we can start with our most important one, 3, 9. We can add the other ones we know. We know that we have an x of 0, which results in a y of 0. We know that we have an x of 6, which results in a y of 0. Might be nice to know what's happening just a little bit further, so we can go negative 1. We can go 7. So let's plug in what we have. Negative 1 times negative 1 minus 6. Negative gives me a positive, so that's basically a wash, times negative 1 minus 6 is negative 7, so together that equals negative 7. All right, so we want to come back 1, down 7. We want to come over to 7, down 7. And we can see from here we're going to end up with a quadratic that shoots up and back down.